Now that you have an understanding of how behavior tree bindings work, let's take a look at the behavior tree for a defender soldier. The root node of a soldier behavior is a selector. When a selector runs, it will attempt to run its first child node. If during execution the child node fails, it will then move on to the next child node. If that fails, it will keep trying each child node in turn until one of the child nodes succeeds or until there aren't any nodes left. Our root node is selecting between two modes, one in which the AI is alive and the other in which the AI is dead. The top node in the alive state is a constraint node, which continuously checks to make sure the AI is still alive. If the AI variable dead is ever set to true, the constraint node will immediately fail and the selector will move on to the dead state. Inside the constraint is a parallel node that repeats forever, running 3 behaviors each frame. The first behavior simply attempts to look for a commander if the soldier isn't already assigned to one. The second behavior is used to detect enemies and record their position. We'll look into that more in just a minute. The third behavior allows the AI to respond to commands it receives from its commander. Right now the primary commands are patrol and attack. There's also a default behavior that sets a default command of patrol if no command is assigned. Let's take a look at the detect and set enemy position node to see how that works. Because the node is a behavior binding, we'll have to look at an individual soldier to figure out which behavior tree is executed for that node. We can see from one of our defender soldiers that the detect enemy threat behavior is executed. We'll switch our view in the behavior editor to look just at that behavior. Detect enemy threat is a great example of how to use sensors to both detect an enemy in your scene and also to remember the last position of an enemy even after it leaves sensor range. The root node of this behavior is a sequencer that performs 3 actions. The first action is a selector that repeats until success. The selector first tries to look for an enemy using sensors. If that fails, it then attempts to assign an enemy based on a known threat, which it retrieves from AI memory. Threats are assigned by the health system whenever the AI receives damage. If an enemy is found either through sensor detection or based on a known threat, then the selector will succeed and the sequencer will move on. If an enemy is not assigned, then the selector will fail and will repeat. Once an enemy is assigned, the next node in the sequence will assign a variable called enemy position to the position of the detected enemy. You can see here that position is a special function that works inside a rain expression. You can use it to get the vector position of different types of objects, like game objects, aspects, and navigation targets. We're assigning the position to a variable so that we can remember the last position of the enemy, even if they duck behind a corner, go behind our back, or otherwise leave sensor range. The final node in the sequence is a timer node set to 3 seconds. We're using the timer to keep the AI from attempting to detect the enemy too quickly. We'd like our AI to keep track and remember the enemy, not just the position, but the enemy object itself, for at least 3 seconds. The timer node is set within a constraint node that checks to make sure our enemy is not null. We're doing that so that if our enemy dies or is respawned, we'll stop waiting for the timer and just move on immediately. One final thing we want to jump into real quick before we finish with enemy detection. You can see that our detect enemy node is not a regular detect node, but instead is a custom action. Let's jump into the code for that and see why.